Thou shalt put no other textbooks before thee in math class. I love math.
A dot plot is useful for organizing a small number of data points. Histogram is effective at displaying large amounts of data. Box composites are effective at visualizing comparing two data sets. Considering this, complete each statement by dragging and dropping the correct answer. So kind of like a vocab test here. A blank is a graphical way to display quantitative data using vertical bars. Histogram. Histogram is a graphical way to display quantitative numbers. A blank displays the data distribution based on a 5-number summary. So the keyword is 5-number summary. This one's also called the box plot, right? So box and whisker plot. What do we got? A blank is a graph that shows how data are distributed using a number line. What do we got? I'd put a dot plot. Number 4, for a set of data, the blank consists of the min, Q1, median, the third quartile, and the maximum value. That one would be the 5-number summary. 5-number summary. That's an A, that's an R, that's a Y. The number of data values included in a given bin of a data set is called the number of data values. So you're counting. Count is a frequency. So frequency is your answer. And another hint why it's not, they wouldn't use, the answer couldn't be bin because you wouldn't use the word in its definition. I wouldn't say, what's the definition of basketball? It's a game of playing with a basketball. Like, it sounds kind of weird, right? So, and then the last one, bin. The bar width, right? So, remember at the bottom of those histograms, that's what we're saying, the width represents the interval data, so that would be a bin is your answer. Alright, question number 5 has a bunch of stuff here. Harry scored a 50. Question number 6, determine any outliers for the data, select all that apply. For outliers, I just need the formula of 1.5 times the IQR, and I want to go below quartile 1, and I want to go above the quartile 3. So I'm going to put those in order. Already done for me. I'm going to have to number these. Let's number these. So 1, 2, 3, 4, 5, 6, 7, 8. That's good. It's even. You like even numbers. There's 4. So IQR is Q3 minus Q1. Okay. So let's figure quartile 1. That's this pink. 4 numbers, take the average, 6 plus 12 divided by 2, and your quartile 1 is going to be 9. And then let's go ahead and work with the numbers up here in green. These are 4 numbers. To find the median, I would have to find the average. 3041 divided by 2, $20.50. Right, so quartile 3 is 20.5. That means my IQR, $20.50 minus $9 gives me 11.5. My QR equals 11.5. So I can use that for both my equations here. I guess it would have been easier if I just calculated. So Q1 is 9 minus 1.5 times this number. Let's just do that since we're here. So 9 minus 1.5 times 11.5. 1.5 times 11.5. This would give me 17.25. And if you subtract those, it'll be a negative. And you'll get negative 8.25 is my lower fence. What does that mean? If you had any negative values to the left of this dotted line is at negative, on the number line, negative 8.25. This out here would be considered a outlier. All right, let's go ahead and try this one. Q3 down here, 20.5. No. 20.5 plus 1.5 times the IQR, 20.5. And I'm just using this number is essentially the same, right? $17.25. So if you subtract those, you will get an upper fence to be 20.5 minus 17.25, $3. That doesn't make sense. Because when I subtracted them, I don't know why I subtract, because I should have just added. And it didn't make sense because I got 3.25, and that would be a super low number. That means all the numbers would be outliers. So 20.5 plus $17.25 would give me a 37.75. Okay, what does this mean? That means any number that's above 37 and going in this direction would be an outlier, and that number would be 56. Now, be careful, these questions are asking determine if any of these, and then it says select all that apply. So it could have been multiple, but there's only one 56. Alright, question number 7. For a school project, 2 students, Shona and Miguel, recorded the number of text messages each of them sent each day for a 60-day period. The box plot summarizes the recorded data. I just want to go over this really quickly. This is your minimum. This is Q1, so this represents between those two dots 25% of the data. This is your median. That means from here to minimum is 50% of your data, or so far each of those are 25%. Quartile 3, 75%, and 100%. Okay. Select from the drop-down menus to correctly complete the sentence. They give us the choices below here, which is the same thing as your drop-down menu. And so let's talk about the median of Miguel's data. So Miguel is the second one here. The median is inside the box, so that is 40. And what I like to do is I really like to write the numbers. So then this one says is blank to the median of Shona's data. So here is Shona's data. I'm going to use little dots. Is 35. So you tell me, what inequality can you write there? It is greater. 40 is bigger or greater than 35. Okay. And okay, here's the second part. And the range of Miguel. So Miguel has a range of a minimum and a maximum. So max minus the min for Miguel is going to be 55 minus 25, which is going to give us an answer of 30. And then Shona's range is 25 for her minimum, and up here is her maximum, which is 60. So 60 minus 25 is going to give us 35. So what inequality would you write there? Miguel's data is smaller than or less than. Okay, then it says, select from the drop-down menu, correctly complete the sentence. Approximately blank of Miguel's data values are greater than the median of Shona's data. Okay, so I know that C represents percentages. So approximately blank of Miguel's data values are greater than the median of Shona's data. So let's figure out median of Shona. Median is right here. Okay, let's make this super obvious. Okay, so I'm drawing that line and I'm comparing. And the question says, approximately blank percentage of Miguel's data is greater. Pen turned off. So what percentage of data, of Miguel's data, is greater or bigger or to the right? So the question is, on Miguel's, what percentage of data is from here to the last part of his box plot? So, but remember, this is his Q1 to his max. And each of these, this is 25%. So this is 25, 25, and 25. So that would represent 75%. Approximately 75% of Miguel's data values, so we go to Miguel, this represents 75% greater than the median of Shona's data. Okay. All right, part B. I think we are supposed to, which of the statements can be concluded from the box plot? Select all that apply. I think from here I need to answer the questions. For approximately 15 days, Miguel sent 50 or more text messages per day. So let's go to Miguel and look at 50 text messages. 50, Miguel, 50. It's getting kind of crazy. Let's erase all this stuff. What was the question? Approximately 15 days. Okay, so from here to there, that represents 25% of the days. And if you multiply 60, so 60 days times 25%, this is going to equal, that's 1/4, right? So 1/4 of 60 is going to equal 15. So I think we're marking true responses. So this would be correct, true. For at least 5 days, Shona sent 55 or more text messages per day. So for at least 5 days, Shona sent 55 or more text messages. Shona, 55. Shona, let's go to Shona. 55. And at least, you're saying at least 5 days. Okay, so 25% we said this this is quartile 3, right? So it's 75%. So this represents 25% of data, and I would say that's about half of 25%, or half of the 25% would be around where she is, which would be half of 15, because we know this represents 15 days, so that would be 7.5 days or less. For at least 5 days, she sent 55 messages or more. I would say yes. There was at least one day in which Shona sent 40 messages. Let's go look. Shona. Yeah, because if you look here, this is her minimum. So, yes, there was at least one day in which Shona sent 40 messages. Yeah. Alright. The number of days in which Shona sent more text messages than Miguel is greater than 30. The number of days Shona sent. Okay, so what they're doing here is they're trying to figure out is this going to represent this is more days, right? How many days does that represent there? And let's double check. No, that's false, because remember we said that each of these represents 15 days. Does that make sense? 16, 15. And then Miguel's is 15, 15, 15, and 15. So, yeah, that possibly can't be more than 15, so no. And then the last one, what color do I have? It's red. Shona and Miguel each sent 25 messages on the same day. Okay, here's the hard part. Although you're looking at this, and you're saying, of course, they both have a minimum of 25, but you're not sure on which day it is. All you know is that one day they sent 25. So that would be false. So the 3 that I would pick as my answer would be A, B, and C is my true. 5 on an English test for which the mean was 50. Okay, I'm gonna underline this one. Mean. And the standard deviation was 6. Here's some good news. You guys have not put those together. We have only done z-score, z equals x minus x bar over the standard deviation. Oh, you can do that. Duh. I just said the formula. And standard deviation is 6. So z-score equals x minus x bar over the standard deviation. Alright, let's do this for math. And I'm going to do the same thing for English. Z equals x minus x bar over s. So let's go over that. Z equals, he scored a 64, so there's my x value. The average is right here, 50. And standard deviation was 6. That means he will have a z-score. Remember, to compare apples and apples, we have to use standardized score. So 64 minus 50 divided by 6 gives me 2.33. And then we do the same thing for the English. The score of wrong. I did the wrong scores. Oh yeah. Okay, let's just do English. English is mostly this side. So just try that again. Harry scored 55. So 55 minus 50 divided by 6. Okay, this gives me the z-score 0.833. Remember, what does that mean? If you have the center, mean, and median are here, a positive z-score is actually going in this direction. So he's actually above the average. That was English. Math, he scored a 64 minus the mean, 59, over the standard deviation of 9. So that'll give me 64 minus 59 is 5. 5 divided by 9 is 0.555. Which one is greater? English. Boo. Part B. What mark would Harry have to score in mathematics for his performance to be equivalent for the English? So let's highlight this. Looking.
Okay, let's go over question number 6. I'm in Desmos calculator. You type in capital X equals bracket, not a parentheses, and you list up your numbers separated by commas, no spaces. At the end, you close the bracket and it'll tell you have 16 numbers. If you type out the word box plot, parentheses, capital X, because that represents all these numbers, and you press the magnifying glass, you will get a box plot. Minimum, quartile 1, quartile 2, which is the median, 50%, quartile 3, and then the maximum. The next question asks you for the mean, so you can either type out the word mean or go to functions, stats, and type in the word mean. Capital X, close your parentheses, your answer is 76.5. They're asking you for the range. I've never done this before, let's try it. No. But you can do the max, minimum, and just subtract the 2, or you can even type that out, max minus the min, and you get 50 as your answer. For the standard deviation, again, you can go under functions and statistics. There's 2 standard deviations. Standard deviation P is the population, which means you have all the numbers, in which case we do. We have all the test scores. The one without the P is called the sample. Let's just say you only took 5 students out of 40 in a class. This is the standard deviation you would do. So this would be dividing by n minus 1. This one's dividing by n. I typed it in the wrong area. You can just copy and paste it, or just you'll memorize it. Just capital X, and your answer is 14.3.
Multiple statements. Let's do the first one. Noah's scores have greater variability. Remember, variability is your spread. So practically, I call it the man. But one of the easiest ways of measuring variability is range. There's also standard deviation, and there's also variance. So let's just look at this with my visual of spread. Looking at Noah's, you put the jam right here in the middle, and it goes this way. So you can do a range, right? 7 minus 3 is 4. for Noah's range, n's range. And then if you did Jada's, Jada has jam or spread all over the place, right? From 7 to 1. So Jada's range is 6. So does Noah have a bigger spread? So, no. The standard deviation of Noah's score is equal to the standard deviation of Jada's. Okay, so you can do this by putting in your calculator. I'm going to quickly put this in. Alright, so if you run through the calculator, they both have a standard deviation of 1.222, so are they equal? And that is true. Now, how do you do that? How do you do that visually? Okay, so if you look at Noah's, here is my center. You have, it doesn't matter how many dots you have, but what matters is how many dots you have on the right side and what's basically symmetrical. You have 2 and 1, then over here you have 2 and 1. Jada's is actually the same because you have 3 dots exactly, and then 2 and 1, 2 and 1. Now you might say, well, they're shifted, right? Jada's center is around 3 and 5, but remember, standard deviation or variability only measures the spread in which it goes away from the center. Does that make sense? Alright. That's very solid stuff. The mean of Noah's score is greater than the mean of Jada's score. So, let's pop that back into the calculator. That's clear. I already have the numbers in there, so I'm going to go stat, calc, stats. I already have list 2 in there, which is Jada's. So Jada has an average of 3. So 5 compared to 3, is it greater? Yes, that is true. Alright, let's try another one. Noah scored better than Jada on every assignment. Okay, so every is an absolute word. So for example, just pick a score like 3. But is that on Jada's score of 5? Is 3 greater than 5? That would be false. So I'm even using math and the visuals, right? 5 is higher than 3, but better means that Noah's score should be bigger than 5. It's not, so it's false. And the last one. Using only Noah's scores, the mean is equal to the median. The mean is equal to the median. Again, you can do this visually. So let me show you the visual way. The visual is, well, what does it look like? This is normal or symmetric. Or another word they use, they call it is a bell curve. It looks like a bell. Taco Bell, the bell, church bell. So when that happens, the mean and the median are exactly the same. On a normal or symmetrical or bell curve graph or distribution, they're exactly the same. So that is true. How do you do that by numbers? You just write out all the numbers and then you'll see if you run the averages. 4, 4, 5, 5, 5, 6, 6, 7. And there are So if you have 9 numbers, 5 is the median. But if you also did the average, it's also 5. So hopefully those quick corrections were helpful.
Yeah, 1 and 1 is 2, and 2 is 2 is 4, 3 and 3 is 6, so now let's try some more. 4 and 4 is 8, and 5 is 10, 6 and